Linear programming is a mathematical model where you model out different problems and mostly simultaneous equations or inequalities, and you end up trying to find the maximum possible or best solution or minimal possible cost solution. So the optimal solution to your equation. And you first do it by graphing your inequalities, shading regions, and then determining sections. So in this video, I'm going to skip through the details regarding shading and stuff. I'll keep them to a minimum. My focus is to be able to break down the questions and solve them. So if you're still unsure about shading and all those skills, please watch the previous videos. So with linear programming, you'll get quite worded questions such as these. So I'll start with this one. So we have, you can pause and read the question on your own. There are a couple of things that are mentioned here that you will need to write down as equations. So one part of the question which I removed here is to write the inequalities that satisfy this. And what I'm going to do is just break them down into different parts. First, is to point out that you have something like a maximum cost that he could use. So he could only use 1.20, so $1.20 to buy those two items. So the peaches and the apples. And we also have something related to the cost. So I can relate those costs to the maximum amounts that I have. Another condition we have is the amount he should buy. So he should get at least 6 individual fruits. What this means is that you could, that in total of buying X and Y, he should have at least 6. So he shouldn't end up with just 5 fruits in total. He should end up with at least 6 fruits in total. But there's an extra condition that he cannot buy more apples than peaches. They're telling you which letters to use, and what we want is the list of combinations that are open. So there are certain numbers that he's allowed to pick, a certain number of apples and peaches that he is allowed to pick that would satisfy the cost, the number of fruits he could have, and this last condition of no more apples than peaches. So that's what we're going to do. And then this is the programming that fits in, and it is to determine the most feasible option. So which combination will give him the cheapest or the most feasible cost. What you're going to do is first write down your inequalities. So the first inequality is associating it with the price here. So I have, if I buy X peaches, then they're going to cost me 20 times X cents, and if I buy Y apples, then they're going to cost me 10 times Y cents. And a combination of this should be less than or equal to $1.20, but because I'm using cents, I need this to be in cents as well, so you need to multiply by 100, so I need 120. Now, what do we put here? Well, the cost can't be more than 120, has to be less than or equal to 120. So this is what you're going to put. So with linear programming, just try to make sure that you simplify the inequalities as much as possible. So if I simplify this, I will get 2x. If I divide by 10 everywhere, I get 2x plus y is less than or equal to 12. So this is my first inequality. The second inequality is that he should buy at least 6 individual fruits. So the combination of the number of peaches and the number of apples should be at least 6. So peaches and apples should be at least 6. So it could be more than 6, but the least it could be is 6. So that's my other inequality. The third one is that he cannot buy more apples than peaches. Careful with the wording. He can buy the same amount. He just can't buy more apples than peaches. So apples has to be less than or equal to the number of peaches. So there isn't any more information. These are all we have. So graphing it, I'm not going to go through the graphing and shading. Please make sure you watch the videos regarding those. So we have they're all an equal to, so I won't have any dotted lines. The first one is going to be from 12 to 6, and then I have 6 to 6, and then the last one is going to be a diagonal. So I'm gonna put the lines in different colors just to show a difference between them. So this line is my, just to show that it's extending, this is my 2x plus y equals to 12. My red one is y equals to x, and my black one is the x plus y equals to 6. So now that I've graphed the different parts, I'm going to start shading the regions I don't want, and I'm just going to use one color for the shading. The 2x plus y less than 12, the region I don't want is this region, so anything beyond this line I do not need. And again, if you want to recall, it's by substituting 0, 0 that I could determine this. The x plus y equals to 6, again, by substituting 0, 0, you're going to see that I do not need this region, just below the black line. Okay, so remember we shade the unwanted and not the wanted region because it gets complicated otherwise. So, and then my last line, the x plus y, I need y to be less than, so I do not want any value above the line because all the values above the red line, so anything here, is when y is bigger than x. So I am left with this lovely region here. And now I need to list all the combinations that he could buy. So if I zoom in here, I just want to show you all the possible values that we could get. So the values are anything that, because all the lines are solid, I can pick all the coordinates on those lines. So that's the first thing, just be worried if it's solid or dotted. So do you go on the line or not? For some lines you will, for others you won't. The second condition is to look into the values. So are you looking at whole numbers? Usually with these questions, they won't ask you for real numbers, so we're looking at integer solutions. We're not looking at real numbers because then you will have infinitely many options. So, and third, you need to look inside the region, not only on the lines. So I have 6, 0 is an option. I have 5, 1. Pick a. I have 5, 1. Trying to pick the best color here. I have 4, 2. I have 3, 3. I'm just going around just to. You could do it any method you want. I have 4, 4. So notice how I'm only like going through the kind of coordinates that I could get. So nothing no half numbers. And then going inside the region, so I have 4, 3 as one of the coordinates as well. Okay, so I have 1, 2, 3, 4, 5, 6, 7. So all the possible values. All the possible values I could get, I'm just going to list out here. So let me just move this down. And these values, if I plug them in into any of these, they're going to satisfy all the inequalities. So that was the whole point. So I have the x values, the y values. So here are all of them. We have 6, 0. We have 5, 1, 5, 2. We have 4, 2, 4, 3, 4, 4, and 3, 3. So we have all of these values. And to answer the last question, which is the linear programming part, I need to determine which one is the most feasible option. So which one is the cheapest? And what I'm going to use is the equation that we found here, but not less without this part. I'm just going to see how much it's going to cost. So I'm going to see 2x plus 10y. So remember, the answer is going to be in cents. So just to determine the cost, you can do the calculations on your own, but if I end up writing out all the values, this will be 120, 110, 120. These are all in cents. You have 100, 110, 120, and then 90. So obviously the most feasible option is buying 3 peaches and 3 apples, and let's say the most expensive options are these. And so these would give you exactly all the money, but 4 will maybe give you like a better combination because you have an equal amount of 2. So yeah, so this is how you would do a linear programming. So if you need more practice, you can watch the next video regarding the same type of topic.